Our last example that we'll take a look at, we're comparing two different babysitters. There's kid-loving Kelly and there's babysitter Bailey. I worked very hard on these nicknames. So we've got to come up with an equation for each one of them based on the given information. So to start off with, maybe we'll color code this a little bit. So we'll stay in red for kid-loving Kelly. So the information about kid-loving Kelly is given to us right here. It says that she charges a flat fee of $10 plus $8 per hour to babysit. So that's really telling us the slope and the y-intercept of the equation that's going to describe what she charges. Now the flat fee of $10, that's going to be your y-intercept, because that's independent of the number of hours that she's going to work. So even if you work 0 hours just for her showing up at the house, she's clipping you for $10. So that's our y-intercept. And then the second part there, the $8 per hour, slope is always a rate. That's what we've seen so far. It's how much you're paying off on the loan per payment. It's how far the asteroid was traveling per second. So the slope is always a rate. And so in this case, it's $8 per hour. So we can just put that as 8. So that means we have an equation, y equals 8x plus 10, which describes kid-loving Kelly. Now we'll switch to green for babysitter Bailey. And so for babysitter Bailey, we're going to figure out her equation from the table of values that we have here. And so we can see that we're going up by 1 every single time here in the x column, and then we're going up by 9 every single time here in the y column. So from our previous study, this confirms to us, since we're adding a consistent number in the x column, we're adding a consistent number in the y column, that this is indeed a linear equation, y equals mx plus b. And so from this we can get the slope. Well, the slope is just going to be that, recall from our first look at slope, the change in y over the change in x, which in this case, change in y, we're going up by 9 every single time in the y column, and we're only going up by 1 every single time in the x column, so the change in x is going to be 1, so that means my slope is going to be 9. Now to figure out the y-intercept, the b for this equation, there's a couple ways that we could do it. One would be to just work backwards in our table. If we see here that we're 1, 2, 3, 4, if we count backwards, so imagine that we had another entry here at 0, so if we go backwards 1, that means we'd be going backwards 9 in the y column, so if I do 15 minus 9, I can get an answer of b equals 6. Or the other option that I have is, once I figure out what the slope is, so once I know the slope is 9, then what I can do is I can take any one of these ordered pairs and plug them in for x and y in my equation and figure out what b is. So for example, if I took this one right here, where I've got 1 as my x and 15 as my y, I can plug in 15 for y, plug in 1 for x, and now I'm going to solve for b. So 9 times 1 is 9, so I'm just going to subtract 9 from both sides, so I indeed end up with b equals 6, just like we did the other way by just working backwards in the table. So whichever way works for you, it's fine by me, but in the end we end up with an equation for babysitter Bailey of y equals 9x plus 6. And we'll use both of these equations on the next slide. So the first thing we want to do is figure out who charges more per hour. So I've brought the two equations over. So kid-loving Kelly, her equation was y equals 8x plus 10. And then if you'll recall, that slope there, the 8, was her fee of $8 per hour that she charged. That was from the given information about kid-loving Kelly. And then in the case of babysitter Bailey, same idea. The slope is representing that rate that she charges. So that's going to be this $9 per hour So by comparing the slopes, we can see that it's babysitter Bailey that charges more. So the slope is what's communicating to us who charges more on an hourly basis. The flip side of that is Kid Loving Kelly. We can see here by comparing their y-intercepts, but that's what their flat fee is. So just for showing up at the door, Kid Loving Kelly charges $10, whereas Babysitting Bailey only charges $6. And so then after that, how many hours is each of these fees the same, and under what circumstances should you hire each babysitter? So the way that we can figure out for how many hours their fees are the same, basically remember that y is that variable that is telling us how much they charge. So if we want the y's to be the same, then we can kind of use a substitution approach, and we'll talk about this more soon, but we can set these two parts of the equation equal to each other. We can say, all right, we want 8x plus 10, we want her fee structure, Kelly's, to equal 9x plus 6 to equal babysitter Bailey's. And so now this is the equation that we want to solve. So we've got variables on both sides. I'm going to move that 8x over here just so that I can move the smaller number towards the bigger. And so then at the same time, I'm going to move this 6 over to the other side. So we end up with 10 minus 6 is 4, and then 9x minus 8x is just x. So it's after 4 hours that the two are going to cost the same amount of money. And if we plug that back into each of the equations, 8 times 4 is 32, plus 10 is $42 for Kid Loving Kelly, and the same thing's true for Babysitter Bailey. 9 times 4 is 36, plus 6 also equals $42. So then the question becomes, under what circumstances should you hire each babysitter? Well, let's test it at 1 hour. Oh, that doesn't spell hour. At 1 hour. So at 1 hour, Kid Loving Kelly is going to cost, come on here, Kid Loving Kelly is going to cost 8 times 1 is 8, plus 10 is $18, whereas Babysitter Bailey is, if we plug in 1, is going to charge only $15, 9 times 1 plus 6. So what that tells us is as long as we're under that 4-hour mark, your better deal is going to be with Babysitter Bailey because her fee is lower at the beginning, but eventually, once we get past that 4-hour mark, we're going to find that Kid Loving Kelly is cheaper because at that point her hourly rate is lower, so in the long run it's going to pay off. So it just depends on the circumstances of the babysitting that you want. But at the 1 hour mark, we want Babysitter Bailey. She's going to be a little bit cheaper.